Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Sticky Notes by James Sinclair, and here are the rules. We need to divide the grid into 6 orthogonally connected 6-cell regions and place the digits 1 through 6 once in each row, column, and region. So what is an orthogonally connected region? It's something like this, where you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from here to here, you can just go through edges this way, all while staying within the region. This would not be a valid example of a region, though, if we tried to connect these, because this cell to any of the cells in this part would have to go through a corner or would have to exit the region while going through edges. Similarly, this would not be valid as a region because these two cells, while they can go to each other through an edge while staying within the region, cannot go to the other cells in the region by going through edges while staying within the region. And this is also known as chaos construction rule set. This is for the 1 through 6 variety, though, not 1 through 9. Each region has a corresponding color. A note outside the grid indicates that the region of that color contains a run of one or more orthogonally connected cells, bounded on either side by a region border or the edge of the grid in that row or column. And the number in the note, if given, is the sum of the digits in these cells. If a region contains multiple sets of orthogonally connected cells in the same row or column, a note only applies to one of them. When notes overlap, the note on top has a lower sum than the note immediately below, and this applies even if a sum is given or not given. So these are the post-its. This is saying there's a run of blue cells, which add up to 19 in row 1. This is saying there's a run of orange cells in row 2, which add up to 4. This is saying there's a run of red cells, which must add up to 8. This is saying there's a run of purple cells or pink cells and red cells in this row, guaranteed, and the red digits must sum to a lower amount than the red one. I think the pink sum, the digits in the pink region must sum to a lesser sum than the red one, or at least one of the pink runs must sum up to a lesser sum than one of the pink runs in this row. And this clue here would mean that there has to be a sum of green sums, a run of green sums, I should say, which must add up to 7. That must be less than a run of red sums in this row. And again, if a region contains multiple sets of orthogonally connected cells, so orthogonally connected just means, again, sharing an edge. So if, say you had something, I don't even know how that would work. Say you had something like, I don't even know how that works. Well, it doesn't work here. Yeah, it just doesn't work here or on any of the edges. But say you had something like red be like this, and then you had pink be something like that. Then one of the pinks then has to be less than one of the runs of the reds, right? So this only says that there has to be one run of pink at least and one run of red at least in this row. There could be multiple ones. We don't know. And you can also find more puzzles like this at artisanalsudoku.com. If you enjoyed this puzzle and want to do more puzzles by James Sinclair, then you can go to his website, which is artisanalsudoku.com. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, we have... there's a blue run in row 1, which adds up to 19. The only way you can add up to 19 with the digits 1 through 6, if they're all unique, which they have to be, is you exclude 2, right? Because 1 through 6 adds up to 21. The only way you get down to 19 is just by removing the 2. So that means you must have a run of 5 unique digits here. So therefore, we have 4 here guaranteed to be blue. And either this is blue or this is blue, and then it exits out. But if we have blue being here, we know we have a blue sequence somewhere. We know we have to have a blue somewhere in column 6. And if you have 5 here, there's no way you can get a blue here because that would then add up to 21 in row 1. So it cannot be blue here. It must be blue here. And we know that the 7 of green must be less than the blue sum in this column. Well, the only way you have something greater than 7 add up to is if you have 2 blues at least in this column. And since we have 5 of them accounted for here, this must be a blue. And we also know that this blue has to be a 2. Okay, so let's mark the edge of the boundaries in dark so that we have it all matching. This is 2, and this blue sum must add up to greater than 7. Well, the only way that can do that is if this is 6. So then this has to be 2 here, because we're missing a 2 in the blue section in row 1. And this is 1, 3, 4, 5. That means to add up to 7, it cannot be 3 digits. If it's 3 digits, it would have to be 1, 2, and 4. But obviously, we have a 2 in the column already. So this must be 2 green digits in some sort of order, adding up to 7. We have 13 in orange in column 5. Okay, red has to go across 4 rows. Could do something like that technically. Yellow also has to go, sorry. Yeah, yellow. Excuse me. Yellow has to go across 4 columns. And it needs 9 here. "13" is at least 3 digits in column 5 for orange. This is a certain color. We don't know what. We'll mark that as medium. Where is green? Well, we know we have 2 greens here. So say it was not including here. The problem with that is it has to go to here, right? And it has to have 2 cells here. So 2 cells here, 2 cells here. The problem is if we tried to connect those orthogonally, then these 2 cells wouldn't have a region. So green has to be at the bottom here. This can't be 3 cells adding up to 7 here because we were listing the 2. So this must be 2 cells. And again, if whatever cell here cannot add up to 7 with a single cell here, because if it did, then these would be the same digit, and they would have to be in the same region, which is not allowed. So this must be here. This must be 3 digits adding up to 7. So it must be 1, 2, and 4, and then we have 2 digits here adding up to 7, so it must be 3 and 4. So therefore, this is 3, this is 4, and we have 1, 2 here and 1, 2 here. That leaves 1 and 5 remaining in column 6. This cannot be green because, again, this is a run of 2 digits to add up to 7. We need a 5 and we need a 6. It cannot be 5, 6 that way, because if it did, there's no way orange could add up to 13 then. It could be 5 and 6 there. So this is a border also. Green could go here and here, or it could go here and here. Either way, this is green then, because it can't go here and here because that would eliminate orange from having digits adding up to 13 because you need at least 3 of them. So we know this has to be 3, so this is orange, which means these both have to be orange. Because there's no other place for them to go, right, to be part of a region. You could have 4 here. Well, this is 6. So no, you can't. It has to be orange, 3 orange here, and then orange must go 1 in one of these cells. We don't know which. And on top of that, this adds up to 6. The oranges in column 5 add up to 13 without 1 or 5. So then it must be 3, 4, and 6 to add up to 13. And that means 2 has to be one of the oranges here. And therefore, this is 2, which means this can't be 2 here. This is 1, which makes this 2. This has to be 5 or 6 here. One eliminates 1 here. This, again, must be 3, 4, and 6 for the orange triplet, which means this can't be 3 or 4. It's 1 or 5. So again, we have 3, 4, 6 here, adding up to 13. We must have 2 yellows here. And since there's 2 yellows here and an orange guaranteed to be here, that means this is yellow. So it's with 2. And it could be 3, 6, or 4, 5. Well, if this is 3, 6, or 4, 5 as the yellow, that means this would be 5 or 6, and the yellow would contain 5 or 6, so this can't be 5 here. It would have to be 3 or 4. So these have to be a yellow-orange combination here. If we had orange here, that would have to connect this way. But the problem is we don't have 1 available in the orange. So that doesn't add up to 5. So this cannot be orange. This must be yellow, which means this can't be yellow. So that's orange and is the 2. We need an orange access here. So it must be here. And this must be a 4. So this is 4, which eliminates 4 in the rest of the column. This cannot be orange because we have that left. And therefore it must be green. So it cannot be 6 here. This must be 5, which makes this 6. Which makes that 1 here. This is not 3 and 6. This must be 4 and 5. Adding up to 9, which makes this 3. So no 1 or 3 here. No 1 or 3 here. We are done. We have boundary here. We are done with orange. We are done with red or green. So we have 4 there. This could be yellow. We have green here, red in all of these. Remaining digits of row 6, 3, 5, and 6. Remaining digits of row 5 are 1, 2, and 4. Remaining digits of row 2 are 1, 3, and 6. And so 2 eliminates 2 there. Yellow has to have 2 digits adding up to 5 in row 1, or column 1, because we cannot have a 5 in column 1 for the yellow region. And we can't have 1 and 4 adding up to 5 in column 1 because we have a 4 already in the yellow region. Which means we must have 2 and 3 adding up to 5 in column 1. So this is basically yellow, and it must be 2 and 3 adding up. Well, we got to connect the yellows together. It cannot go this way because that's too many digits, and it would block these two out, so it must be these 2 digits specifically. So this is yellow and is done. We have just red and pink left. Okay. And these reds must add up to 8. So you have either this is 1, 2, 5 adding up to 8, because you can't have 4 in the row. And if that were the case, it would eliminate all possibilities for this cell here. So this has to be 2 digits adding up to 8 for the red here. So it must be 3, 5, or 2, 6. Huh. Okay. Remaining digits in column 1, we have 1, 4, 5, 6. No 4 here. In row 3, we have 1, 2, 3, 5, 6. In row 4, we have 1, 3, 4, 5, 6. So again, to add up to 8 with 2 digits, which it must be because you can't add up with 3 digits in row 3, because that would eliminate that all possibilities for this cell, it has to be either 2, 6 or 3, 5. So red here must be greater than 7. So it has to be either 3, 5, 3, 6, or 5, 6 here, or all 3. But the problem is, again, in row 3, red has to have 2 digits adding up to 8. So that's, again, only 2, 6, or 3, 5. Well, no matter what combination of digits here has to be part of red, it must contain 1 out of 3 or 5, guaranteed. Because you can, again, have 3, 5, 3, 6, or 5, 6, or all 3. But the problem is if you have all 3, that's going to eliminate all possibilities for red adding up to 8 here. So this must be 3 and 5 in the red here, which means red has to be, again, this has to be red, period. And it could be either red, red, or red, red. So it has to be 2 and 6, which will add up to 8. Which eliminates 2 and 6 in the rest of the row. This can't be 6. It's 3, which makes this 6. That eliminates 3 in the rest of this row. And 6 in the rest of this row. So you could have 2, 6 here, and then go across there. Red has to be bigger, okay, than the pink in row 5. Well, if red is 1 here, say it went 1, it only has 1 digit in row 5. It has to be 4 then. So 4, you can have 2 going this way. There has to be 2 on the edge there, and or 2 on the edge there. Therefore, these are both pink. And this cannot be 4, because 4 is on one of the edges. This has to be 2 reds, so this is red here. And is 3 or 5. Yellow has to be greater than red here. So if we don't have, we have to have red here. So it has to be then all 4 reds here. And this must be 4. This must be 1. This has to be 6 and 2. And this is done as a region here. And that leaves this as 5 and 3, which makes that 6. 2 eliminates 2 here, so that's 1. This must be 2. These are all pink. 6 eliminates 6 here, so it's 1 and 6. 1 eliminates 1 here, so it's 5 and 1. This can't be 1, 2, 6, so this must be 5. This 5 eliminates 5 here, so it's 4 and 5. That leaves this as 3 and this as 4. And that's a solution. So, fairly straightforward. Yeah, fairly easy. I guess that's the 6x6 chaos construction. I've yet to find a 9x9 chaos construction which actually is easy, because it usually involves a lot of execution based things, and then you don't necessarily have easy logic either, right? Sometimes I think I've ran into one where it had fairly easy logic, but then the execution was still fairly difficult, and then definitely challenging level. So, but 6x6 is much easier because there's less things to take into account. So, but very cool. Nice little 6x6 chaos instruction. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.